Well, good morning, everyone. I'll go ahead and start. If anybody has any questions over homework or anything else. No questions. Okay, so we are here on our schedule. We're on the 20th here, and we've already covered all of this. So I talked last time about possibly going back up and doing our conversions, but I've had a change of heart on that. And I think what I'd like to do is try and get polynomial functions and their graphs done today. And then once we do that, then on, let me see, on Thursday, we'll try and do rational functions. And then next Tuesday, we will do a review. So this day will be a review day. And then we'll have our exam next Thursday. Okay. So I just think that we're going to continue graphing, and that's what we've been doing. So rather than go and do conversions and then come back to graphing, I figure we just finish off the graphing. So that's kind of the idea here. All right. So if there's no questions, we'll go ahead and start with today's material, which we're going to talk about polynomial functions and their graphs. So up to this point, okay, I'm going to ask you to recall what it is that we can graph at this point. We know how to graph lines. We can graph, let's see, first we can graph lines. And those are functions that look like this. F of x equals mx plus b. So that's where we find the slope, we find the y-intercept, right? We plot the y-intercept and then we go rise over run. Okay, so lines, very straightforward. Okay, the second thing that we know how to graph are quadratics or parabolas. And that's what we spent the last week or so on. That's anything that looks like this, ax squared plus bx plus c. And we know that there's a whole set of steps on how to graph those. So right now, those are the only two things we know how to graph. Now we're going to talk about polynomial functions. And the set of steps to graph these is completely different than the set of steps for lines and quadratics. So we're going to have a whole new set of steps and a process to do this. But before we can begin, we have to establish what a polynomial function is, and then also what they look like. So we know lines are straight, we know parabolas look like U's that either open up or down, but what do polynomials look like in general? So let me give you a few examples of what polynomials look like written as functions, then we'll go look at their graphs, and then we'll go see if we can graph them. So your first example of a polynomial function is this one. How about x cubed, let's go x to the fourth minus 3x to the third minus 4x squared. So what you're going to notice is that we have x's raised to different powers. And notice that each of those powers is a positive, or I should say a non-negative integer. Now, what do I mean by non-negative integer? A non-negative integer is basically a number that comes out of this list of numbers. 0, 1, 2, 3, 4, 5, forever and ever. So a non-negative integer is one of your counting numbers, like 1, 2, 3, 4, 5, but it also includes 0. So notice that all of the powers on x here are non-negative integers. That's what you need in order to have a polynomial. You have to have a bunch of terms with x's in them, and the powers on those x's have to be non-negative integers. Now, there's no restriction on just how big the power can be. So I can give you another example. Here's another one. This one's going to look a lot like the one we just put, the one I just put up there, just a slight little change on that. So notice there again, the powers 7, 6, 5, those are all counting numbers, non-negative integers. But that is definitely different than the one before it, right? Because you have a 7 instead of a 4, 6 instead of a 3, and a 5 instead of a 2. Now, I don't want to mislead you because there's nothing that says a polynomial has to have 3 terms. You can actually have fewer terms. You could have something like this would be a polynomial, x to the 9th minus 4x to the 7th. That would be a polynomial. There it only has 2 terms. You could have something like this, x cubed minus, you think here, 3x squared plus 4x minus 12. That would be a polynomial function. That has 4 terms. So basically a polynomial is just a bunch of terms with x's raised to non-negative integer powers. So there's so many different kinds that we can have. Now let me ask a question here. I haven't called on y'all in a while, so I think I'm gonna start calling on some people here. So let's see, Patrick, is Patrick around today?
Yes, sir, I'm right here.
There you are. How you doing, Patrick?
Good.
Good. So Patrick,
Yes, sir.
I'm going to write a function down here. So my first question, Patrick, is that a quadratic function?
Yes, sir.
Okay. Is it a polynomial?
No, it's a binomial.
Powers, the powers that are on the x. What did you say? I'm sorry, I spoke over you.
Wouldn't it be a binomial since the power only goes up to 2? The power.
Okay, so it would be, the power is 2, right? This power is 2. The power here is a 1, right, on the x. Are those non-negative integers?
Positive, yes.
Yeah, they are, right?
Mm-hmm.
So what I'm telling you, what Patrick is kind of also alluding to here, is that a quadratic function is actually a polynomial. Okay, it falls into the category of polynomials. So when you look at quadratics over here on the right, we didn't know it when we were doing it, but a quadratic is an example of a polynomial. Okay, let me ask somebody else here. Thank you, Patrick. How about Denise? Is Denise here? Mendoza?
Yeah.
Hey, so what about, with that same idea, Denise, what about a good old-fashioned line? Would a line be a polynomial?
Yes.
Yes, it would, okay, because the power on the x is a 1, right? And so that would fall into the category of a polynomial. So we've actually already studied polynomials, but we've stuck to just 2 different types, lines and quadratics. One more. Let me ask someone else. How about Sebastian? Sebastian here?
Yep.
Hey, Sebastian. This one's a little tricky. F of x equals just a constant. I'm just going to give you the number 5. So if we graph this, this would be a flat horizontal line. So Sebastian, do you think that that is a polynomial?
I'm not sure, but I'm going to say yes.
Yes, that is correct. Now, what we don't see here is that there's actually an x behind this raised to the 0 power, because anytime we raise something to the 0, we actually have a 1. So that's the same as 5 times 1. So that's a tricky one. I didn't mean to trick Sebastian. He went with his instinct. It's a line. It is a polynomial. So when it comes to polynomials, there are a few things that are important to us, all right? One thing that's important to us is the highest power of x that we see. Okay, so the highest power of x, let me do a different color. It might not come out too good on your side. When it comes to polynomials, let me type something up here. A polynomial is just a bunch of terms. Oops. raised to non-negative integer powers. Okay, that's what we've already established. The highest power we see is called the degree of the polynomial. Okay, it's called the degree of the polynomial. So if we look back up here at these polynomials that I've given us, let's talk about the degrees. I'm just going to write down to the side of each one of these what the degree is. So let me see here. Let's call on Kiera.
Hello.
Hi, hey, I got your stuff. I didn't reply to you, but I did get your email, okay? So Kiera, I'm asking for the degree of the polynomial. So look at this first one up here that I'm circling here in orange. What would the degree be?
4,
4, okay. How about the next one, Kiera?
7,
7. Next one?
9.
9. See, this is very straightforward, isn't it, everyone?
Yeah.
You're just looking for the highest power. So the next one would be 3, and then 2, and then 1. And then what about the last one?
1
So what's the power you see on X?
was 0.
0. Okay.
Okay.
So that's the trickiest one out of all of them. Because you have to remember that we really wrote this, that X to the 0 wouldn't be there, right? On this one, it would just be 5. So if you ever see a number by itself, the degree of that is 0. Okay, that's important. I'm going to put that back in there though. Okay, so the degree actually will tell us a lot about the graph of these things. Okay, the degree is going to tell us a lot about what these things look like. All right. The other important thing that we are going to need to know is something called the leading coefficient. So let me just tell you what it is. The leading coefficient is the number in front of the highest power of X. So we have two new kind of definitions here. We have this thing called the degree of the polynomial, and we have the leading coefficient of the polynomial. So let's go to a different student. So all of these things that I put here were the degree. And then now I'm going to put the leading coefficient. And by the way, I'm going to abbreviate leading coefficient with LC. Okay, so the degree and then the LC. So let's see here. How about Beth? Beth Rodriguez? You around today?
Yes.
Okay, Beth, can you tell me what the leading coefficient is for this first one? So what is the number that you see in front of the highest power of X?
1.
1. Now it's hidden, right? It's really a 1 here. Everyone see that? So the leading coefficient here is 1. Aren't they all 1? 1, 1, 1. Okay, this one's not. So this one was 1, this one was 1, this one was 1. How about this one?
It's 3.
3, that would be a 3. So leading coefficient there would be 3. And you want to keep going, Beth?
Sure.
Next one.
4.
4, and the last one?
5.
5, okay. So how do y'all feel about that? Is that pretty straightforward? If you're asked to find the degree in the leading coefficient, you could do that. Now, like I said, that's going to be very, very useful to us. All right. So now let's take a break from this. Let's go look at some of these. So I'm going to bring up some graphing software here. And I'm going to just put in here a polynomial. So watch what I'm going to do. Let me just do an example. I'm going to do X. You tell me, X to what power? Someone just throw a number out there.
7.
X to the 7th, okay, plus, I'll just throw some 3x squared minus 5x. There we go. Okay, there's the graph. Okay, does that look like a straight line? No, right? Does that look like a parabola? No, because it does this weird squiggly thing, right? You can zoom out, you can zoom in on this, all right? Let me change it. We said x to the 7th. Let's do x to the 5th, okay? So everyone watch what happens to the graph here. Ready? Did it change? It did change. Here's what I'll do. I'm gonna copy this, make a copy of it. Here's the first one we did was x to the 7th. Let's do that one in blue. So the blue one and the reddish one are they're different, right? But don't they have the same basic shape? Right? They have the same basic shape. Let me try it again. Let me copy this one. And instead of using x to the 5th, let me do x to the 3rd. And let me change that color to green. Let me zoom out so you can see this. Do you see that all of these kind of have the same basic shape? Right? They all kind of do the same thing. They all kind of do a squiggle up and then a squiggle down and then back up. Now, would you agree that it appears that in all of these cases, the left side of these graphs goes down? Do you agree with that? These left sides start to go down. And the right sides of these seem to go up. So the left is going down and the right side is going up. Yes? For all of these. Okay, let's talk about the degree of each of these. The degree of the first one is 7. The degree of the second one is 5. The degree of the third one is 3. So they're all odd numbers. Do y'all see that? What I'm going to do now is I'm going to make some copies of these. I'm going to run out of colors here. Well, maybe not. Now watch what happens if I change these powers to even powers. So I'm going to go 4th here, 6th, and 8th. Okay, so they're getting hard to see. Let me clear the screen here. Okay, so they're in there. I'm going to have to hide. Let's hide the odd ones so they don't get in the way. They're all the ones that are even. What do you notice about those? They all kind of look like parabolas, don't they? They all kind of do.
Yes, sir.
But what's happening on the left and the right for these?
They go up.
Okay, so on the left, they all appear to be going up, and on the right, they all appear to be going up also. Now that's not like a coincidence. That is what happens when you have even powers. So that's why I said the degree is very important, because it's going to tell us about the shape of the graph. So let me clear a bunch of this out, and don't worry, I'm going to summarize all of this, and I'm going to write it down in a nice way that you can take notes on it. I just want you to kind of be paying attention to what's happening here. So let's go back. Let's look at. Let's do an odd one and an even one together here. So let me do 4th. Oops. Go ahead and graph those. Okay, so the red one is an odd one, odd degree, and the blue one is an even degree. Now, what do you think's going to happen? Let's look at the odd one right now. What do you think's going to happen if I change the number in front to, like, let's say 3? Let's do that. If I change it to 3, watch what happens to the graph. Did much happen? I mean, it did move, right? Let me change to a different number. How about 6? It changed a little bit. How about 8? It changed, but is the left side still going down, the right side still going up? It is, right? So that number in front is like shrinking or stretching the graph. It has that effect. but it does not have effect on the left or the right side going up or down and up respectively. Now, pay attention here. What if I change the number in front to a negative? So watch what happens here. I'm going to put a -1 in front. Here it comes. Whoa. That changed a lot, didn't it? So in terms of the shape changed completely. But what's happening to the left side now? Doesn't the left side look like it's going up and the right side is now going down? It's like things switched, didn't it? It switched, and that's what's going to happen. A negative in front is going to flip everything. So let me get the let's do the quadratic. Here's the not the quadratic, the even degree. There we go. If I put a number in front of it, like 3, it doesn't change much. 6 doesn't change much. -2, whoa, big change, right? Big change. But now the left side goes down and the right side goes down instead of up and up. Okay? So if you're going to take anything away from this, here's what you want to take away. All polynomials that have an odd degree look about the same. All polynomials that have an even degree look about the same. The only difference is what happens on the left and rights. Okay, and that a negative in front changes things. So let's get back to our notes, and I'm gonna just kind of summarize this. I just wanted you to see what polynomials look like. They look like roller coasters. Okay, they're squiggly, curvy graphs. Okay, so here we go. Let me summarize this. We have this thing that we use to help us graph polynomials, which is called the leading coefficient test. Maybe I should capitalize this because it is a test. The leading coefficient test. I should also mention to you, with your test being a week and a half away, that I am going to allow you to create your own cheat sheet for this test. Cheat sheet meaning you can write your own formulas down, because there are a lot of things you're going to have to remember how to do. Graphing parabolas, graphing polynomials. So all the steps that we write down here, you can write down. The thing you cannot do on your test is you cannot, on your cheat sheet, you cannot just work out examples. It has to be just notes and formulas and things like that. Okay, leading coefficient test. So here's the way this works. This is a little bit weird when you first see it, but just follow me on this. Just write this down. What we're going to do is we're going to draw a table. Okay. Now, on the top of the table, I want you to fill this in. Degree even, degree odd, and on the left side, put leading coefficient positive, leading coefficient negative. So let's talk about what would happen in this scenario. So the way this table works is you look into this box. This box would mean that we have a degree that's even and a leading coefficient that's positive. Does that make sense? If you're looking in that yellow box, it's an even degree and a positive leading coefficient. If you ever have that, here's what we can say. The left side of the polynomial will go up. The right side of the polynomial will go up. And what happens in the middle is a big question mark. We actually don't know what happens in the middle, but we'll be able to figure that out. Does that make sense, the way this table works? I mean, I have to fill it in for you, but you have to understand what each box means. So in the green, Who wants to tell me what the green means? We have a what and a what? I can call on someone too. How about Leah? I know Leah's here. She was just here. Leah Gomez? Anastasia? No? Tatiana?
Yes, sir, I'm here.
Okay. Doing okay today?
Yes, I'm fine. How are you?
I'm doing good. I just want to make sure you understand how this table is working.
Okay.
So in the green, that would be a polynomial that has a what degree?
That is an odd degree,
Odd
but
degree.
a positive leading coefficient.
Okay, good. So in that case, what's going to happen is the left side goes down and the right side goes up. And in the middle, put a question mark. We don't know.
Okay.
Okay, so this table right here that I'm drawing, I would put this on the cheat sheet, your formula sheet that you're allowed to have on the test. Okay, this is a reference for you. Okay, let's talk about the blue. In the blue, is there anyone that doesn't understand how to determine the degree or the leading coefficient for each of these boxes? We're okay? So in this case, if you have an even degree and a negative leading coefficient, it's going to go down on the left, down on the right, and in the middle, we don't know. And then the last box, which I'm running out of colors, I guess purple might work. That would be the left side goes up and the right side goes down. In the middle, we don't know. So again, the leading coefficient test, what's great about it is that by just knowing the degree of the polynomial and knowing the leading coefficient, just those two little pieces of information, you can tell me what the end behavior is. So this right here tells you the end behavior of the graph. It doesn't tell you what's happening in the middle, but it tells you what's happening at the end. Okay? All right. Let's go back and look at some graphs again, because now we need to talk about the middle, because there's a lot of things going on in the middle. All right, so I'm going to get rid of this. Let's start fresh. Okay, so let's take a look at this one. X to the fourth minus 2x cubed minus 6x squared. Okay, so the degree of this polynomial is what? What's the degree of this polynomial?
4.
4, and the leading coefficient is
1.
1. So this has a degree of 4, a leading coefficient of 1. So the degree is even, and the leading coefficient is positive. And according to our table, if the degree is even and the leading coefficient is positive, it should go up on the left and up on the right, which it does. Do y'all see that? It does go up on the left and it goes up on the right. So these continue, these graphs continue up forever. The question is the stuff here in the middle. Like what is, like all that stuff, you know, everything happening down here, oops, down here, like all of this. Like all this stuff, can we figure that out, right? That's the part that we said is undetermined. This was the big question mark, right? This was the big question mark at that we didn't know, right? So how do we do that, right? Can y'all see that on this graph? Do we have any x-intercepts? So remember, x-intercepts are anywhere where the graph touches or crosses through the x-axis. Can y'all see x-intercepts? Yeah.
Yes.
Yes.
So I see them. I see them here, 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 right? I see those 3 x-intercepts. So maybe it might be useful for us to be able to determine those, to figure those out on our own, right? Where our graph might have an x-intercept. Now, I also want to point something else out here that's really important, which is something we're going to use here in a moment. And that is on this first x-intercept right there, would y'all agree that the graph like actually crosses through the x-axis? Like it actually comes down. It actually comes down, the graph comes down, goes through the x-axis and continues. Do y'all see that? We actually cross through. But what about at the second x-intercept? Does our graph cross through? No, it goes up and it just barely, how would you say that? Maybe it just kind of like touches right there. So here it crosses, but here it touches. Sometimes I use the word bounces because it's almost like a wall. It bounces off the wall. Do y'all see the difference there between those? Now that we're going to need that later. Right here at this x-intercept, our third x-intercept that we have in this picture, does it cross or does it touch? Same thing, right? Cross, just like the first one. Okay. Now watch what I'm going to do. I'm going to change this problem. All I'm going to do now is I'm going to change the degree. Okay, so watch what happens. You know what? I'll copy this. Let me turn it off first. Let me put it in here first. Okay, so here it comes. All right, so that graph right there, that's in green. See that green graph? I'm going to clear this out. Do you see that the green graph has the same x-intercepts as the blue graph? Do you see that they have the same places, right? Same places. But does it do the same thing? Let me hide the blue one. What happens at the first one? We cross through, right? We cross. The second one, do y'all see we cross through again? And at the third one, do you see that we cross? So for this polynomial, we cross through it, all of them. All right. So let's get to the steps. Okay, I think I've shown you enough to at least know what the basic ideas are behind this. Let's actually get to the graphing. All right. So here we go. So how to sketch polynomials. How to sketch polynomial function. All right, first step. We're going to use leading coefficient tests. To determine the end behavior. Yeah, so all we're going to do is we're going to look at the degree, we're going to look at the leading coefficient. It's going to tell us what the left and right hand sides are doing. Okay. Once we do that, we're going to go to step 2. And step 2 is usually the hardest step. Step 2 is we are going to find the x-intercepts. Find the x-intercepts and determine if we cross or touch at each one. All right, now that step right there is the hard step. So let's talk about how you do that step. Okay, to do step 2, the first thing you're going to do is set the function equal to 0. That's how we've always found x-intercepts. We always set the function equal to 0. So we're going to set the function equal to 0 and we're going to solve. This is probably going to take factoring. Okay, so that step is going to require that we factor, most likely. Now, this next step, just write it down, and if you don't understand it, that's okay, because we're going to have to work out an example for you to see it. The next step is to determine what's called the multiplicity of each factor. You'll see, just hang tight. Determine the multiplicity of each factor. If it's even, you will touch. If it's odd, you will cross. And then the third and final step is to actually draw the sketch. And to draw the sketch, the first thing you do is the x-intercepts. Next thing you do is the end behavior. And the last thing you do is connect. Okay, so we're going to do an example. For now, let's just have these steps ready to go. All right, you ready to do an example? Here we go. It's our first one. Okay, I want us to sketch f of x equals x to the 4th minus 2x cubed minus 8x squared. All right, this is a polynomial function. This is not a quadratic, right? So first step in our process, step number 1, is to determine the end behavior. All right, let me call on someone. So I'll go back to the people who didn't respond but are still, I know they're here. How about Leah? Are you there yet or not?
Yes.
Okay, Leah. So I'm asking for help on step 1, which is to use the leading coefficient test to determine the end behavior. So can you tell me, do you understand that step, what you're going to have to do?
Yes.
Okay, go ahead.
So you're going to have a positive, and since it's positive, leading coefficient.
So you're saying the leading coefficient is positive?
Yes.
What is the leading coefficient?
It's the number in front of the x.
Okay, which is for us?
1.
1. Okay, good. I'm just making sure that it's clear for everyone. Okay, so leading coefficient is 1, which is positive. I'll bring the table up for you in a second. Positive. And then the degree?
Degree is 4, so it's also, or it's even, so both the sides are going to go up.
Both sides are going to go up. Good.
And
Okay, so the left side goes up, the right side goes up, and in the middle, we don't know. All right?
yeah.
Good job. So we're just going, Leah's going off of this table here. The degree was even and the leading coefficient was positive. Both sides go up. Okay. All right, that's step 1. Let's move on to step 2, the hard part. So the hard part for step 2, and we'll move on to, let's see. Is Anastasia there? No. How about Jesus? Is Jesus here?
They're
How's it going, Jesus?
surviving.
You sound tired. I got your test done for you, yes?
Y-
Think I
Yes.
updated the grade? Yes?
yes. Yes,
Okay.
you did.
Okay, so Jesus, on step 2, we have to set the function equal to 0, right? Now, this step I said is going to suck because you're going to have to factor. So Jesus, do you have any idea how you would start factoring that? Do you remember what the first step for factoring is for anything? It's been a while since we factored.
I honestly don't remember right now. Sorry.
Okay. Okay. How about if I tell you this? G C
GC. I keep thinking GCE, but that's
GCF, greatest common factor. That's always the first thing you're ever going to want to do when you factor something. So is there something that all of the terms have in common? Well, they all have is right. And they all have at least 2 x's. So that means we can factor out an x squared. And then in parentheses, we leave enough space for 3 things. Do y'all remember doing that? It's been like, since the beginning of the semester. But this is, this is the most basic form of factoring there is. So we have to know how to do it. Okay. Lauren, are you around?
Yes.
Lauren, with this GCF, I pulled out an x squared. Can you tell me what would go in here?
Yes. So the first one would be x squared again,
Okay,
and then minus 2x,
good.
and then minus 8.
Good job. Okay, good. Equals 0. So we have factored, right? We have factored. And now what we have to do is we have to continue factoring if there's more factoring to be done. And we can see, hopefully you can see that this is a quadratic, and that also could factor. So, I mean, I kind of have bad news here, but we have to see if we can factor this. Which means we have to go back to how we do this. And it's been a while since we've done anything like this. Do y'all remember me telling you, you take the number in front, you multiply it by the number in the back, you get -8. Then you take the number in the middle, -2. You're trying to find 2 numbers that multiply to be this, but add to be this. Does this look familiar? Do y'all remember doing this? Patrick?
No, I don't remember.
I do.
I mean, I know we did it. We didn't do a whole lot of it in the beginning of the semester, but we have to be able to do this in order to do polynomials. So what can y'all, does anyone have any questions on what I did here? By the way, this is called the AC method for factoring trinomials. You take the number in front, 1, multiply times the number in back, -8. You write that number down. You look at the number in front of x, -2. And you now have to think mentally of 2 numbers that multiply to be -8 and add up to be -2. And those 2 numbers are -4 and +2. Right? If you take these 2 numbers and multiply them, you get -8. But when you add them, you get -2. So those numbers you have to be able to, like, again, mentally come up with. Now, once you do that, then what you can do is break this down. You rewrite x squared. You rewrite the -8. But in the middle, instead of writing -2x, you write -4x plus 2x. You're using these 2 numbers to rewrite -2x.
Wait, so I got lost. Where did we get the -4x from?
I had to think of that. So we had, hold on, let me see here. We had these, you're okay with where these 2 numbers came from, right? Okay, now at this point, I put mult next to it, multiply and add next to this. You have to sit there and think about two numbers that multiply to be -8. Okay, so let's just think about some numbers that multiply to be -8. -1 times 8, right? 1 times -8, 2 times -4, -2 times +4. That's about it, right? Those are the only numbers that multiply to be -8. But you also need that when you add the two numbers together, you get -2. So the only two numbers that would qualify would be these two. Does that make sense, Patrick?
Yes, sir. Now this
Okay.
I had forgotten, but this looks familiar.
Okay. Yeah, we're kind of digging up old stuff here. Okay, so any questions on that? Any more questions? Once you do that, you rewrite, what we're doing is we're rewriting -2x as this. I mean, you have, when you look at this, you can see -4x plus 2x would become -2x. But the reason we do this is so that we can split this and factor it by grouping. So now I'm going to do grouping, which means I look at just the first two and I pull out a GCF. So out of these two, what they both have in common is an x. You're left with x minus 4. And in the second two, you can pull out a +2, and you're left with x minus 4. And then from there, since they both have x minus 4, you just write down x minus 4. And then the two things in front, you put in its own parenthesis. Now look, some of you in here, I know already from high school, know how to go from here to here without doing any of the steps I just did. And if you can do that, do it, all right? I'm just trying to show you a method to get to it if you don't know how to do it. So this would be a good point in time that if you feel like holy shit, what's going on here with all of this? This would be a good time for you to say, hey, I need to maybe get some tutoring or visit my office hours where I can give you some problems where you have to use the AC method to factor. But don't leave that as an unknown thing, because that'll come back to haunt you on the test. All right, so here we go. Next step, I'm going to rewrite this. And now I know that that breaks down to be x minus 4 times x plus 2 equals 0. Okay, so now I have this thing completely factored. Everything's broken up. And so what we can do is we can set each factor equal to 0. Okay, so I'm going to have 3 separate answers here. So on the first one, what number squared is 0? So what's the only number you can multiply times itself and get 0?
0.
0 itself. Okay, so that's one x-intercept. Okay, on the second one, just add 4 to both sides. So you get x is 4. On the next one, subtract 2 on both sides, so you get x is -2. All right. So we have 3 x-intercepts, right? Does anybody have a question up to this point? We have used the leading coefficient test to determine the end behavior. We know that both ends go up. We've tried to find the x-intercepts by setting the function equal to 0 and solving, and we had to factor. We have not determined the multiplicity yet. We have not figured out whether or not we're going to touch or cross at each one of these x-intercepts. All right. So let me give you kind of a preview. I don't want you to do this like during, if you were doing this problem, I wouldn't want you to do this at this point. I just want you to be thinking about what we know at this point. What we know is that we have these x-intercepts. One of them is at 0, one of them is at 4, and the other one is at -2. We also know that the left side goes up and the right side goes up. That's all we know at this point. We're going to now figure out at each one of these x-intercepts at -2, at 0, and at 4. For each one of them, we have to figure out if we touch or if we cross through. All right. The way you do that, pay very close attention to this. The way you do that is you go back up to the line that you had where it was factored. Okay. This is where we're going to determine the cross, the cross of the touch. I don't want to do that. We're going to use that to determine cross or touch. And the way you do it is as follows. And this is the part that most students get confused with. Let's start with the x equals 0, okay? That x equals 0 came from that factor, right? X squared. What is the power on that factor? So what is the x being raised to? The second power, right? And that number 2 is even. And if you have an even powered factor, what did I say in the notes would happen here? If you have an even powered factor, you will touch, right? You will touch. So that tells me that I'm right under here, I'm going to write touch. I'm going to touch here at this 0. Now let's go to the next one, 4. Where did that come from? It came from this factor up here, right? What's the power on that factor? It's tricky because it's not written.
1.
It's a 1. You see that 1, everyone? That 1 right there? And that's odd. See, the part that people mess up most of the time is when they're trying to determine this thing called the multiplicity. That's what we're doing right now. They don't look at the power up here. They look at the number itself here. So they'll look at the number 4 and they'll be like, oh, 4 is even, so I must touch. No, you have to go from the factor it came from and look at the power on the factor, and then that'll determine whether or not it's going to cross or touch. So we have an odd power. Odd power, it says we cross. So I know that I will cross here. And let me call on Ashlyn P. You here, Ashlyn?
I'm here.
So maybe you can help now on this last one, -2. Can you tell me if we're going to touch or cross?
It's gonna cross.
Cross. So you come up here, you're looking at the power. The power is a 1 because it's not written, and that means you cross. Okay, good. Now I'm ready to draw my picture. Ready to sketch this thing. I'm going to do it right here just so we can have all the information on one page. So we have our XY axes. All right, here we go. For steps for sketching. First, we're going to put the x-intercepts on our graph. Okay, we're going to put the x-intercepts there. So here my x-intercept is at 0, at 4, 1, 2, 3, 4. You don't have to be super precise here. Just make sure you get them in the right order. Here's 4, and at -2, x-intercept. When I'm done here today, I'm going to copy all of these notes as a PDF file, and I'll send them through the chat to you, okay? That way you'll have them. All right, so we do that. Then it says end behavior is next. So we know both left sides go up, right? I mean, left and right sides go up. So what I'm going to do, notice I'm going to just come over here. I'm just real gently kind of draw a little arrow going up to the right here and to the right here. All right, here's where it all either comes together or falls apart. You're back in kindergarten at this point. You're just connecting the dots, but you have to follow the rules. So what I'm going to do is I'm going to start here on the left-hand side. I'm going to start drawing this graph, and I've got to go and get down to that point, right? We've got to get here. Now, what is going to happen when I get there? Am I going to cross or am I going to bounce? Or am I going to cross or am I going to touch?
Cross.
At -2, right? I'm gonna cross through, right? So let me do that. I'm gonna cross through. Okay, now I've got to get back to 0, right? Connecting dots. But what do I do when I get to 0? I have to touch, right? So that means I'm going to go up, I'm going to turn back up, I'm going to touch it and kind of bounce off that x-intercept. That wasn't a very good. Try it again. That's a little better. And then I've got to go back and go through and cross through at the 4. And then once I cross through, you can see that I can connect the left-hand side, connect the left and right-hand sides together. And that's the graph. That's what we want, okay? That's it. Everybody in this class is going to have a slightly different looking graph. Someone else might have done something more like this. Maybe they drew their arrow here and their arrow here, and then they came through, and maybe they went down real far and then came back up and bounced off and then came through and did that. And that would give you, you would get perfect credit for that. You both get a perfect score on those. All right. There's going to be variation. So how, these little sections right here, right there, don't have to match. All right. For each of you. We don't care about how low those little pieces go. You actually have to take calculus to figure out how low those pieces go. But we're not doing that here, obviously. Okay. So this is a little bit involved. Would you all agree? There's a lot going on here. So what I'd like to do is I'd like to give you one to work on right now. All right. Everyone here loves bonus. All right. So I'm going to make this, since we don't have any quizzes in this class, this is going to be a problem that I'm going to count as a bonus. You'll have to turn it in when you turn in your exam next week. So next week, you're going to be taking your test. You're going to have to scan all your pictures or scan all your work and send it to me. You'll put this as the last page. Okay. Understand? Now, here's what we're going to do. I want you to work. I'm going to put you all in a couple of breakout rooms. Just in case y'all want to talk to each other, y'all can, okay? Because the factoring on this one is going to be a little bit tricky. Maybe, it might not. I'm going to actually give you 2 of them. Okay, that's the first problem. Second problem is going to be okay, hold on, let me okay. Okay, so we've got 15 minutes. What I'm going to do, I'm going to let you work for 15 minutes. At the end of 15 minutes, I'm going to bring everyone back here. At that point, everyone is going to show me on their camera real quick. You're just going to hold up your work to your camera, just like that, just so I have an idea that you've actually worked today and done something. All right, it's going to be a real quick like that. And then if you don't finish it today, you can turn it in later for the exam. But I am also going to base the bonus on whether or not you hang out for the next 15 minutes and participate. All right. Any questions? I'm going to break you out right now. Groups. I'm going to do like groups of 5, I think. Just make sure you're back here in 15 minutes to discuss things, or in about 14 minutes. Breakout rooms. Okay, there's gonna be about 4 or 5 people in each room. So go ahead and join the room. I'll pull everyone back in a little while.
Hello? Did he send that thing in the chat? Hello, sir?
Sorry, I got pulled away for a minute. Sorry about that. I know we've gone over here on a minute on time, but I got pulled away for a moment. Okay, so at this point, if you have the ability to share your camera, just real quickly hold up what you did to the camera, and then as soon as you hold it up, you can take it down and you can leave the class. We'll come back on Thursday. We'll do more of this, and then, like I said, maybe get into rational functions, and then we will get ready for the test next week. All right, everyone, have a good day. Thank
All right.
you.
Thank you, sir.
Were you going to send the notes?
I did. I emailed them
Okay,
through
awesome.
Canvas. Yep. I put them in the chat also here, but if you want, you can just get them off Canvas.
Okay, thank you.
Mhm.